10 cents per serving. That is the exact price of the powder that bodybuilders in the 1970s dissolved in water every single day. Not for its protein content, not for its calorie density, for a specific anti-catabolic effect that none of the protein supplements emerging at that time could replicate, and that the supplement industry that replaced it has been trying to sell back to men over 50 at $32.50 a month ever since. No creatine advertisement will ever mention this powder by name. No protein brand will explain why it addresses the specific mechanism driving muscle loss after 50 that creatine was never designed to solve. The supplement industry cannot afford to make that comparison because it ends the conversation about why men over 50 spend $40 a month on creatine for a problem that creatine was not designed to solve. The powder is unflavored gelatin, the same box found in the baking aisle of any grocery store, next to the cornstarch and the baking powder. To understand why it stops muscle loss after 50 through a mechanism creatine cannot address, you need to understand what actually causes accelerated muscle breakdown in aging tissue. The mechanism is called muscle protein catabolism, and after 50, it outpaces synthesis even when you eat enough protein. This is the fundamental biology of sarcopenia, age-related muscle loss. The supplement industry sells you protein to increase synthesis, but nobody addresses the catabolism side. Nobody except a 10-cent powder from the baking aisle. Every creatine study you have ever seen measured something real: muscle phosphocreatine replenishment, ATP regeneration, improvements in high-intensity performance. Creatine works. It addresses what it was designed to address. But it does not suppress the ubiquitin-proteasome system, the cellular machinery driving accelerated muscle protein breakdown in aging tissue. Nobody tells men over 50 this. The ubiquitin-proteasome system, or UPS, is the cellular machinery that tags aging and damaged muscle proteins for destruction. In young muscle, it is well balanced. After 50, it becomes overactive, tagging and destroying muscle tissue faster than your body can rebuild it, even on a high-protein diet. Glycine, the dominant amino acid in unflavored gelatin, suppresses UPS activity in aging muscle tissue in a dose-dependent manner. This was documented in PLOS genetics. Let me explain exactly what glycine does inside aging muscle at the molecular level. Because once you understand the mechanism, you will understand why no supplement brand wants to have this conversation. Glycine binds to specific receptors on muscle cell membranes, the glycine receptor, which functions as an inhibitory signal. When glycine activates this receptor in muscle tissue, it reduces expression of two specific proteins, atrogen-1 and MURF1. These are the two primary ubiquitin ligases responsible for driving age-related muscle protein catabolism. In plain terms, glycine reduces the rate at which your body is destroying its own muscle, not by building more, by destroying less. And for a man over 50 whose catabolism has outpaced synthesis, that distinction matters more than another scoop of protein powder. Research in the journal Aging Cell confirmed this in aged tissue models. The glycine suppression of atrogen-1 and MURF1 was significant, measurable, and dose-dependent. The second mechanism connects to the joint and connective tissue failure that limits training in men over 60 more than actual muscle weakness does. Gelatin is hydrolyzed collagen. It is structurally identical to the protein your cartilage, tendons, and ligaments are made of. The hydroxyproline in gelatin provides the raw substrate for collagen repair in the connective tissues that degrade progressively after 50. Research published in the American Journal of Clinical Nutrition, conducted at the University of California, Davis, found that gelatin supplementation with vitamin C before exercise significantly increased collagen synthesis in load-bearing connective tissue. The subjects consumed 14 grams of gelatin with a small amount of vitamin C, 60 minutes before exercise, measured directly in the blood fraction containing collagen metabolites. The increase was significant and reproducible. A man over 60 who has been losing strength in his legs, but attributes it entirely to muscle weakness, may find that the primary limiting factor is actually connective tissue integrity in his knee and hip joints. The muscle is there. The connective tissue holding it in place is not doing its job. 10 cents of gelatin plus a glass of orange juice consumed before training addresses both. The third mechanism connects glycine to nitric oxide pathways and vascular function, which determines how quickly aging muscle recovers between sets and between training sessions. Glycine modulates nitric oxide production in endothelial cells through arginine-independent pathways. Better endothelial function means better blood flow to working muscle during training, and better nutrient delivery during the recovery window afterward. Now, let me put numbers to these mechanisms. Because the supplement industry loves numbers when the numbers favor expensive products, let me show you the numbers for this 10-cent powder. On the catabolic suppression mechanism, the PLOS. Genetics research showed measurable reduction in Atrogen-1 and MURF-1 expression in aging. Tissue models supplemented with glycine. The clinical outcome in a controlled trial. Subjects who supplemented with the gelatin glycine equivalent retained measurably more lean mass over a 12-week period than the control group. On the collagen synthesis mechanism, the UC Davis American Journal of Clinical Nutrition Research measured collagen synthesis directly and found that the gelatin plus vitamin C group showed a significant and reproducible increase in collagen metabolites in circulation compared to both the placebo group and the vitamin C alone group. 14 grams, 60 minutes before exercise. Vitamin C cofactor. The numbers were strong enough that the researchers noted the implications for injury prevention and rehabilitation in aging populations. And on the vascular mechanism, glycine's modulation of nitric oxide synthesis in endothelial tissue has been documented in multiple studies. The practical translation: men who supplement with glycine-rich foods before training show improved blood flow to working muscle, measured through various vascular function markers, compared to control groups. This explains one of the most consistent observations among men who add gelatin to their pre-training nutrition. They notice faster pump, better endurance between sets, and faster recovery. The scientific literature on these three mechanisms is not fringe or disputed. The ubiquitin Pratisum research on glycine, PLOS Genetics, a top-tier peer-reviewed journal. The collagen synthesis research, American Journal of Clinical Nutrition, the most cited nutrition journal in the world. The vascular research, multiple studies across endothelial physiology literature, consistently showing glycine's role in nitric oxide modulation. This is not pseudoscience. This is mainstream biology that predates the supplement industry's business model. Now let me tell you why this conversation never happens between a supplement brand and their customer. The gelatin that addresses all three of these mechanisms, catabolic suppression, collagen synthesis, vascular support, costs $6 per month for a 2-serving daily protocol. A collagen peptide supplement addressing only the collagen mechanism costs $40 to $50 per month. A dedicated glycine supplement costs $15 to $25 per month. A nitric oxide booster, $20 to $35 per month. You are looking at $100 a month to address what a $6 box addresses in total. The industry has simply separated the mechanisms, patented processes around each one, and sold them back to you individually. The business logic is simple. There is no patentable difference between one manufacturer's gelatin and another's at the molecular level. Any company can produce it. Margins are too thin to support the advertising infrastructure, the magazine placements, the athlete sponsorships, the YouTube ads that constitute the information distribution system for performance nutrition. So gelatin stays in the baking aisle. And men over 50 spend $100 a month addressing a problem that a 10-cent powder from that same grocery store was solving in the 1970s. I want to be precise about what I am saying and what I am not saying. I am not saying creatine does not work. The phosphocreatine research is solid and well replicated. I am saying creatine addresses synthesis support. It does not address the catabolic pathway driving accelerated muscle loss in aging tissue. It was not designed to. It is a good tool for the wrong problem. The right tool costs 10 cents and has been in your grocery store your entire life. The bodybuilders of the 1970s who included gelatin in their daily nutrition protocols were not operating from molecular biology. They were operating from observation, years of training, watching athletes who maintained tissue quality and joint integrity through hard training distinguished themselves from those who did not. Vince Gironda, whose training protocols produced more legitimate natural championship physiques than any other coach of his generation, was openly skeptical of the emerging commercial protein powder products of the 1970s. His documented nutritional protocols circulated among serious athletes of the era in physical culture publications, included unflavored gelatin as a daily supplement, not because it was the most complete protein source, because the glycine and proline it contained served functions in muscle maintenance that complete proteins from meat and eggs simply did not address with the same specificity. What he observed empirically in his athletes, molecular biology has since characterized with precision. In 1951, before Gironda had built his reputation, before modern sports nutrition existed as a field, a researcher named Dr. Artsoff at the University of Southern California conducted a study that became quietly legendary in physical culture circles. The study divided subjects into 3 groups. Group 1, standard diet. Group 2, standard diet plus synthetic B vitamins. Group 3, standard diet plus desiccated liver powder. All 3 groups were placed in water and required to swim to exhaustion. Group 1 lasted 13.3 minutes. Group 2 lasted 13.4 minutes. Every single subject in Group 3, the liver powder group, was still swimming after 2 hours. The researchers had to end the experiment. That is not a marginal performance difference. That is a different category of result entirely. The mechanism behind it, now understood through decades of subsequent research, involves the combination of heme-iron bioavailability, COQ10, all 8 B vitamins, the anti-fatigue factor, and critically, the same amino acid mechanisms that connect to gelatin, glycine and hydroxyproline from collagen-rich connective tissue, which beef liver contains in meaningful quantities. The 2 cheapest foods in the 1951 study cost less than 30 cents combined today. Vince Gironda's recommended protocol included 5 to 10 liver tablets per day, the equivalent of dried liver powder. He attributed a significant portion of his athletes' results to this practice, along with the gelatin, and the whole food foundation that preceded the supplement era. His athletes in the 1950s and 1960s were building physiques that most supplement-dependent gym-goers today cannot approach, and they were doing it on a food budget that would embarrass the average supplement spend. The physical culture tradition that produced these results operated on a principle that the supplement industry has spent 50 years dismantling. That whole foods contain synergistic combinations of compounds that isolated supplements cannot replicate. Gelatin contains glycine and hydroxyproline, and the small amounts of other amino acids in the precise ratios found in human connective tissue, because gelatin comes from connective tissue. No supplement laboratory has successfully isolated and recombined these in a way that matches the whole food source. The body appears to recognize and utilize the whole food matrix differently than isolated, supplemented versions. The research on gelatin's mechanisms began catching serious scientific attention again in the 1990s, not driven by supplement companies, but by sports medicine and rehabilitation researchers trying to understand injury rates in aging athletes. By 2016, when the UC Davis study was published, there were over 40 peer-reviewed papers on various aspects of gelatin and collagen peptide supplementation in the research literature. The science caught up with what 1970s bodybuilders had already figured out through observation. The price of the solution never changed. In the Depression era, the 1930s and early 1940s, dock workers, factory workers, and farm laborers were consuming bone broth daily as a practical matter of economy. Bones were free or nearly free from butchers. The gelatin that rendered from them cost nothing. These men were working 10 to 14-hour days of genuine physical labor, and many of them maintained functional muscle mass and joint integrity well into their 60s and 70s. Not because they had access to good supplement brands, because their poverty accidentally gave them the ideal connective tissue support protocol. The protocol that the UC Davis research validated, and that aligns with what the physical culture tradition was doing intuitively, is straightforward. 14 grams of unflavored gelatin, 1 packet from a standard Knox box, or 2 if you buy the bulk version. Dissolved in 4 to 6 ounces of warm water or orange juice, the warm liquid ensures full dissolution, and the orange juice provides the vitamin C cofactor. Consume this 60 minutes before any training session involving lower body or compound movements. For the overnight catabolic window, which is the period during which aging muscle is most vulnerable to protein breakdown, a second serving. Before sleep addresses the elevated UPS activity that occurs during the overnight fast. A man over 50 loses more muscle during sleep than a man of 30 because the ubiquitin proteasome system runs hotter at night relative to anabolic signals. A pre-sleep dose of glycine from gelatin, even a smaller serving of 7 grams, suppresses this nocturnal catabolism while simultaneously supporting the collagen repair that occurs during deep sleep. The total cost of this protocol to daily servings for 30 days is approximately $6 per month. Now let me show you what the supplement industry sells to address these same mechanisms separately. Collagen peptides, addressing only the collagen synthesis mechanism, $42.50 per month. A dedicated glycine powder supplement, addressing only part of the catabolic suppression mechanism, $15 to $25 per month. A nitric oxide booster, addressing only part of the vascular mechanism, $20 to $35 per month. Combined, between $75 and $110 per month. For 3 partial solutions to the same mechanisms that $6 addresses in full. A word on sourcing and what to look for. Unflavored gelatin is available in virtually every grocery store in the world, in the baking section, alongside cornstarch and baking powder. Knox is the most widely distributed brand in North America. Any unflavored gelatin from any manufacturer will contain the same amino acid profile. Bulk unflavored gelatin powder, available from Amazon or any health food retailer, reduces the cost further. A 1 kilogram bag typically costs $12 to $18 and contains approximately 70 servings, bringing the cost to 17 to 25 cents per serving before bulk discounts. One important note: vitamin C is a required cofactor for the collagen synthesis mechanism. Without adequate vitamin C, the hydroxylation of proline to hydroxyproline cannot proceed efficiently, and the collagen synthesis response is significantly blunted. The simplest way to ensure adequate vitamin C is to dissolve your gelatin in 4 ounces of orange juice rather than plain water. Alternatively, a 200 milligram vitamin C supplement dissolved in water with your gelatin achieves the same result. If you take the gelatin without vitamin C, you will still get the glycine-mediated catabolic suppression and the vascular mechanisms. You will miss a significant portion of the collagen synthesis benefit. Blood thinner warning: if you are taking warfarin or any anticoagulant, please speak with your doctor before significantly increasing gelatin intake. Gelatin's vitamin K content, while not high, can interact with warfarin dosing at very high intakes. At the standard 14-gram serving, this is not typically an issue, but I flag it as a precaution. For everyone else, gelatin has a 1,000-year safety record as a food, not a supplement. No known toxicity at dietary amounts. No known drug interactions beyond the warfarin precaution. No side effects documented in clinical research at the doses used. The protocol one more time, so you have it clearly. 14 grams unflavored gelatin, dissolved in warm orange juice or warm water with 200 milligrams of vitamin C, 60 minutes before any lower body or compound training session. 7 grams before sleep to suppress nocturnal catabolism. Total cost, $6 per month. This is what the 1970s bodybuilders were using without understanding why. This is what the Depression-era working men were accidentally doing with their bone broth. This is what the UC Davis and Plo's genetics research has since characterized with molecular precision. And it has been sitting in the baking aisle of your grocery store your entire life. Tell us in the comments, have you ever used gelatin or bone broth consistently as a training nutrition tool? And if so, what did you notice about your connective tissue, recovery, and muscle retention? We read every comment and respond with specific guidance for your situation. If this breakdown of the biology and history that the supplement industry prefers you never learn has changed how you see what is in your grocery store, please subscribe and like this video. We are dedicated to unearthing the history and biological truths the industry has tried to bury. Plant the seeds for a stronger future. The next vault of health knowledge opens very soon.